Morning, sir.
Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So, in the last class, we basically focused on discussion about the polymorphism, one important feature of C++ or any other object-oriented language. I think you all got the slides and lecture videos, right?
Yes, sir.
Hmm. Okay. What we found is we do some analogy in terms of the uh, keywords or the terminologies, and one point that we found is the library function the libraries that we include in C++ compared to C. So there is a small difference. So here we have got class definitions, and here we have got predefined functions and procedures, but here we have got class definitions and also pre-declared objects. And there is a level of abstraction that we experience, and for the sake of writing compact codes and readable codes, it is useful, it is necessary, and object-oriented languages provides a higher degree of abstraction. And all the recent languages, they provide uh, abstraction to the probably to the highest extent. So writing codes, uh, at least you don't really have to bother about how much space it consumes, what is the type of the data and all this. So one can really concentrate these days on specifically the algorithm and the algorithmic steps rather than the storage and the low level details regarding the memory or the register, right? So as we mentioned, we'll be talking about class নিচ্ছে এখন কি হচ্ছে এটা এখন করা যাবে না so we'll be focusing on C++ as a language to study the object-oriented programming. So this is what we found, and this is the picture of Brian Stroustrup. Many of you can identify this person. So he's the inventor or designer of the C++ compiler. So he, in fact, during his PhD, so he faced a lot of problems while dealing with C codes because of low-level details, and whenever the code becomes very large, the application becomes very large, it becomes very difficult to handle and modify, and all this reuse becomes difficult. So he failed the problem in uh, late 60s. Okay, and he then, after the post PhD, he thought of doing something, and those days there was a language called algol, which was meant for algorithmic implementation. If you have got an algorithm, using algol you can implement and the computer will execute it. So algol, it was also there. Now uh, he thought that, and algol got a variant of it in form of simula, that was another language derived from algol. So he thought of, because he used C, so he thought of writing something C with classes. So it was actually named, it was just a kind of exercise which was not a part of his, I think, any say company where he joined, or any kind of work. So he just voluntarily, I mean, he just started thinking of, can we add something extra into C which will have the additional features or of this algol language, which was basically object oriented, which has got the features of an object, or the definition of object can be implemented there. So it was in late 70s uh, when he was writing this C with classes. Now that was in a very naive version, and during 80s, early 80s, he thought of extending it to add input output features, like instead of printf scanf that was in C with classes came with a different way of accepting and taking inputs and outputs. That was, these days we know, I mean, those who already know C++, it is the use of C in, C out, and the concept of stream classes, IO stream class, O stream class, I stream class, like that. So those developments those portions of the codes he wrote during this period, and it was in 1985 he was able to publish usable version, I mean a commercial version or whatever, so that people can use. Now why he actually thought of extending C? Because C those days, which was Richie Cunning and those who developed, that was very popular, used in most of the platforms, servers, or maybe small PCs those days. So he thought of that if I can extend C, the syntactically people will be more eager to use it, and but it will also come up with the advantage of having object-oriented concepts implemented, so that large programs can be easy to manage. So that was the idea, and the C++ started its journey from 1985, and then it took a lot of time to and a lot of debates that what should be the standards, like what will be the interface, what will be the libraries that will contain, and all the details. Overall, the syntax will be more or less looking like C. That was not a problem, but it was in 1998 that it got some standard, ISO standard. Okay, and then with time, in 2003 there is some other version. So it was when he published it, it was C++ version 2, and then version 3 came after another 4-5 years. And during those 2002-3, it was more or less a very popular language which implemented object-oriented concepts. And there are uh, many softwares which got implemented using C++ as a language, and there are very big some big applications also. You can click on this Strauss-Troop homepage, where you will have the list of applications who actually used C++ to develop their products. And in fact, Apple used extensively to develop its products and all. So there are many examples, and it is better if you click on this, you will find a number of applications, the video lectures, or interviews, and many things on C++. And as you can see, with 2011, then after that it was 2011, 14, then regular basis there are some modifications, few enhancements in C++ that took place. But as a language, as you can see, this is a multi-paradigm language, because as we know that if you don't understand any object-oriented concepts, still you can design and run your codes. It's not like Java that you are bound to know C plus object-oriented concepts to write a Java code. So this supports procedural as well as okay, just a minute. So this supports procedural as well as object-oriented uh, paradigm. So it's a multi-paradigm language, and that is why it is so popular. You can have a mix of both. So in C++, the code, you can write isolated functions like the main function and all this, but you can also write classes, and within the classes you can encapsulate functions and or methods. Okay, and so here are some of the that I have copied it from the wiki page. You can always refer to that. So these are the learning resources in terms of the NPTEL lectures. You can always follow the lecture series by Professor Parthaputim Das from IIT Kharagpur. So it was in 2016, and it was a programming in C++, assuming the understanding of C. So probably it fits to your skills, those who are switching from C to C++. So it's a very nice lecture series, and extensively discusses about the coding part, the philosophy, the design philosophy, and how the compiler handles the details. So it is not like a C++ codes that or C++ language the way you read it in your school days. It's more of focusing on the design aspect, like as a programmer, or I mean as a designer, how you design the object oriented concepts, why you need these concepts, and the several debates that we'll also talk about while talking about inheritance, multiple inheritance, and all this. And also he focuses on the small syntactic issues, in his lectures. And Professor Ranade, his lectures are very recent, and he actually introduces the language from C++ as a language. So there were no prerequisite of C that is required in his course. But more or less, these two are useful and very recent courses. So you can always refer to that. They are having YouTube links also free to use. These are the books I think I have already forwarded it to you, the soft copy of the books. As I mentioned, so Brian Stroustrup, he wrote the book, the C++ programming language book, that was in long back in 90s, and that uh, uh, as I mentioned, in our college days, C++ was just a fancy. So if you know C++, you can earn nice jobs and all this. So this is a book that people used to follow, and then he wrote several other books also on C++ with time. And there are other books like this Prusical book, which I'll be referring during my lectures. This is a good book, the volume 1. The volume 1, in fact, talks about the basic C++ features or basic object-oriented features and the syntax, and all those details like why it should be like this, what the compiler should do, all the details. Like as I mentioned, the during polymorphism, during operator overloading or function overloading, the compiler decorates something, does something in the background, which we are not aware while we write the code. So all those details are nicely explained there. So as I mentioned, even though you know C++ quite well, I would suggest you to, I mean, specifically those who know it, they should read this book so that they know the underlying philosophy of implementing such a language, how the abstraction is actually implemented uh, by the compiler. Okay, because as a computer science student, you are not just supposed to implement algorithms. You must also know that what internal overhead at times the system need to bear to uh, provide you the abstraction. And sometimes you probably you would not look for too much of abstraction, rather you want a very fast code to run. Okay, so those details you should know. And the second volume basically deals with the advanced topics like STL templates and multiple inheritance. So those of which still raises some debates in the design and analysis of object oriented softwares. Okay, and in fact there are courses not just talking about object oriented programming, rather object oriented design and analysis. So it is object oriented uh, analysis and design, OAD or OAD or whatever you say. So there are full-fledged courses that talks about it. There are design issues. And this is a Scott Mayer's book. This is also a very popular one. And this is a competitive programmer's handbook. So those who deal with competitive programming using C++, this will be good. There are nice tips given here. And this is Adam Drozdiak book, which actually is a data structure book where the data structure algorithms are implemented using C++. Okay, there are almost in every say chapter, it talks about a mini project, right? So those projects are like full-fledged codes which are useful utilities and completely written using C++ features. So this is a book where you just it's not like a Balaguru Swami or Kanitkar book uh, meant for uh, like those maybe non-computer science students. So here you have the hard-coded these data structures starting from stacks, queues, and till the point of B trees, B plus trees, and all this, right? Multi-way trees, hashing, whatever you think of. Okay, try. So all sorts of advanced data structures, they are being explained and also implemented using C++. So you have a nice idea that how we can use all those features, and they have designed the classes, they have designed uh, the subclasses and all. So this is a nice book that will give you as a programmer how you write C++, how you use C++ to implement data structures for computational purpose. And this is a book that entirely is dedicated on discussion of standard template library. Now, templates we just mentioned in a very brief, that if you know, if you have got a design template, so that you can use the template to create a data structure of a particular data type, right? So if you have got a stack template defined in the template library, then you can use that template library, that stack template definition. You can just write stack and you can create an integer stack, you can create a floating point stack, you can create a character stack. So just writing one line of code, so you instantiate that. So these standard, so instead of these days, instead of having class libraries, normal class libraries, these days the languages or C++ language is having a very rich standard template library. Okay, so template library means you so just one library caters to different types of data uh, having the same data structures. But there are other details also. There are container classes and all. So this use of standard template library probably helps us in writing or developing fast codes. You don't have to write even the normal or very common data structures. You don't have to write a stack code, you don't have to write a queue code, not even a tree on all this. So using the standard template library, you can develop applications very fast. Okay, so this is something important, but I don't think we'll be able to put too much of emphasis in STL because the course is so vast. There are so many features, but I'll try to touch upon maybe a couple of classes on STL if possible, right? And you can write your own standard template library also. You can add something of your own in the STL, or write some templates which is having the similar philosophy and interface, and those will be challenging. So now let's focus on the first C++ code. Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
A bit louder because I cannot. I don't know.
Yes,
The
sir. Yes, sir.
microphone or the
Yes.
speaker is having
Yes,
some
sir.
problem. And please try to interact whenever I ask. Otherwise, I feel like either the connection is off or whatever, because I cannot see your faces also. That's a big problem. Uh, I've switched to the full screen mode so that you get the maximum visibility of the slides and whatever I show it here. Okay. So can you see the both the codes? So what is the purpose of this code? It's already written in the comments. What is the purpose of the code?
So the first one is the C code, the second one is the C++ code, comparing both of them.
Sir, to convert Fahrenheit to Fahrenheit convert.
Yes, to convert temperature Fahrenheit to centigrade. So that's probably the most simplest thing that we can think of, just ending up with a few 7-8 lines of code, right? So to the left we have got the C code, to the right we have got the C++ code, and uh, so this C code, those who know just C, so just focus on the C code and find out if there are some issues here. Is that fine? Whatever I written here. So what I did, there is a small comment line. Sorry. Oops, problem. So there is a small comment line, and then I'm including the library function, then the main, and then there are two variables that I've declared, and I'm giving a prompt to the user, just reading the value
Sir,
of
you
the
didn't write
Fahrenheit.
int man.
Hello? Yes.
Sir, you didn't write int man, only man int.
A bit louder.
Sir, you didn't specify the return type of the main function. So I think.
Yes, I understand. So I just come to it later on. So this is, so if I don't specify anything here, even if I don't write void, what is going to happen if I compile? There will be some warning
It's
messages,
void.
right? So if you can write void, you can write int, whatever. So but it will give some kind of void, warning messages. I come to that. Yeah, that I have intentionally skipped that. Anything else? If you just try to point me out. So I'm reading the value of Fahrenheit, and then I have given a comment line. So again in C, sorry, so it was okay. So I've given a comment that conversion formula, and then this is the formula. So we all know this. So this is the typecasting. So what is this? This is, we have typecasted it, right? And then we have printed the output, and then there is a do you want to continue. Then we have scanned the character value, and if it is y in smaller caps, I go back, otherwise I exit. So what is this f flash stdin? Have you ever used it?
Yes, sir. Sir, generally after the entering any character, so the enter also remains in the input stream. So that F plus stdin flushes out the enter character.
Yes. So whenever we are pressing, so say I keep pressing the keys, or I keep pressed for some time, so this will generate some signals converted to characters like ASCII codes or whatever, and that will be stored in the input buffer. So associated with the keyboard, which is a input device, there is an associated buffer. So for any input output device, there is a associated buffer. So whatever I am trying to display in the monitor also, or in the printer or somewhere else, there will be some buffer. So when the computer tries to pass on some information to the outside world, there is a buffer. Buffer means a small storage, a temporary storage area, a kind of memory you can think of. Whenever we are trying to take some inputs from the outside external world also, there is some buffer. Now keyboard being an input buffer, when you press keys unnecessarily, or I mean you make something, so you are not sure that whether the buffer is, so whenever you are reading, maybe you are reading some items from the buffer, but the rest are still remaining there. So if that is so, so if I execute scanf %c, so at times if the machine finds that it's already, the buffer is having some item which is actually for you it is garbage, because you didn't want that to remain. So that garbage, it will read the garbage and will consider that to be the value of the variable c, and that will create problems. So what happens, if even if I write scanf %c, it will not stop for the value to be entered or whatever key to be pressed, and it will simply accept the garbage value and do whatever it wants. Maybe it will exit, or maybe it will compute the garbage value and all this using the garbage value. So that's why you give f flush stdin. Flushing means you just clean the garbage, because anything that you don't want is treated as garbage. And stdin means standard input. So this is the buffer associated with the standard input. So like stdin, you have got for the output, whenever computer wants to send something to the outside world, there was std out. So here we are we are trying to deal with the problem of input. So that's why we have flushed stdin. Okay, and then this is return 0. We are returning, and we are not, but we have not any specified return type. So maybe we can just remove it here. Okay, now can you see the equivalent C++ code, and can you try to find out the small differences that we have encountered, or that is there,
So
assuming that this
number
code
one,
is
the
perfectly
inputs
okay
are
and both the codes will run.
so the
Might
inputs
there
are
will be some warning messages that we'll see. I'll learn it, I'll run it in my machine also, and will show you. But before I do that, let us focus on the differences, and we'll then elaborate on the differences, and we'll start continuing. So what is the first difference?
input methodology, sir. Sir,
The very
in
first line, is there any difference?
sir, the package is different. The
Hmm?
package is
The
different.
Hash
The header the header file is different, sir.
no,
IOStream instead of
even prior to that, even prior to the header file.
Sir, comment line.
Yes, the comment line, you see. So it's just like I gave you two figures, and I asked you to find out how many differences are there. It's just like that. So in the very first line, you see here the comments are written, how the comments are, this is the first difference. So how the comments are written here in C, the comments are written like this. Okay, it's a single line comment. And if you have got multiple line comments, you write this, and you give a comment like this, right? But in C++, you have got, definitely you have got this option, but you can also have this option. So this is single line comments. Okay. In C plus in pure C, if you have got the single line comment, you have to do something like this. So the problem is if it is a very long line of say, so this is C plus plus type and this is C. So the point is if you have got say 150 lines of characters, 150 characters in a particular line, so you have to basically browse to the end of the line and then you have to close this comment in C. But in C++, it is enough to just add these two slash to make the whole line as commented, right? So this is one just simple handy tool. There is no additional design issue or whatever, right? And in fact C++ is C compatible. That's why you are it supports both of it. So you can do this also and you can do this also. Because there are two lines, I have given single line comments in both of it instead of a block comment. This is very trivial, but the next important difference that comes, as you pointed out, is the library function. So what this library and what is it? Is there any difference of these two libraries? The purposes are the same, but what is the basic difference here?
Sir, IOStream contains classes also along with classes and objects along with the general procedures and everything.
Yes. So definitely the content, so whatever these libraries contain, definitely it will differ. We'll see that how they differ. So the thing is, but in terms of the purpose, the objective, the stdio, the purpose, why we include it and use it. So it contains printf, scanf, the definitions of printf, scanf, and also whatever all the details, and this IO stream, it will contain the similar things which is equivalent to printf, scanf. So let's see what it is. Now what is the next difference? What is the next difference?
Sir, it has a return type and the parameters have void instead of just an open bracket close bracket.
Yeah, so the point is whether you write void, whether you write int, that is definitely an issue. But the thing is, in C++, you simply cannot write a function as, you cannot declare a function something like this. So what it says that you cannot simply be so casual in not mentioning the data types or the types of the arguments, even if it is no arguments are there. So in this case, so in C, even if you are allowed to do something like this, although it is not always recommended, but in C++ you simply cannot do this. So you have to write here void. হ্যাঁ সুজয় আমি ক্লাসে আছি okay, got the point? So in C++ you are not allowed to skip the specification of argument types. Even if you find that nothing is accepted and nothing is returned, you have to specifically write void and void. Void means nothing is there. I mean so that is the case. Now why we are forced to do this? Can you give the reason for this? In C, even if you write this, it will be compiled. But in C++, if it is a C++ compiler, it will try to, because it is C compatible, it will be giving you enough warnings and all. And if you ignore those warnings, you might get into a very disastrous outcome later on. So
Sir,
why
because
C++ compiler focuses on or emphasizes on specifying the data types?
Sir, because of the polymorphism thing, sir, for example, if there are uh, multiple functions the same name, the function signature is very important for differentiating between them. And like I remember you taught us during the advantages of C++ that both importance to like encapsulation and the privacy settings give importance to both data as well as methods. So is that a reflection of that?
Yes, more or less you are correct. The point is whenever you speak, whoever speaks, speak a bit louder. I don't know, I'm not getting the sound in a proper way. Anyway, I mean, but the recordings are perfect. What I found, so might be that my speakers are not that good enough or creating
Okay, sir. Okay,
problems.
sir. I'll speak
Okay,
louder, sir.
so
No problem.
the point is, yeah, it is absolutely correct. So what we found during polymorphism, so same function names uh, can be used in different context. Context means the same sum can be used with int, float, int float, and all this. So you see, sometimes you say that, okay, I write here sum 6 and I write here sum 6.0. Now for a C programmer, is there any difference between these two? Sum 6 and sum 6.0. For a C programmer, is there any difference? Do you make a big difference out of it?
First, in C, both are the same.
Yeah, I mean, although you know that this is not the same, but you say that, okay, I have written I have written a sum function with integer argument, but even if we pass 6.0, it will be typecasted to integer and it will work. So I am happy with that. But as a C++ programmer, you are strictly forbidden to do this, because it might happen that uh, you have got one which it accepts integer and one which accepts float, and you intend to uh, have different body of functions because function names are same, and it is allowed in C++. So thing is, in C++, the type checking or the data type is very important, and the distinction between the data types are often important while you plan or you write polymorphic codes, polymorphic functions, and you overload them, right? So this is important, and this is a good practice right from the beginning, that you don't skip or you don't be so casual while specifying data types. Okay, variable or object types you have to specify, but even when writing functions also, you should not, if it is void, you should write void. So such things which I probably I remain reluctant here, but here it will not allow. The compiler will start shouting, and right from the beginning might be indicating warnings, and if I keep ignoring it, so at some point of time, while I implement polymorphism, implement templates, because templates also, you see, based on the data type, the entire definition, it's a integer stack template, it's a float stack template. So it's not only data, but the type of data is also important and should not be ignored in this way. So that's why in C++ you should not leave any of these as so. You may think of like main. I don't write anything here. I write int as a return type. So that is also not allowed. Okay. So just to summarize, so in C++, type checking is extremely important. So this is what we call, it's a strong type checking is ensured in C++, and that need to be, as a programmer, you need to keep in mind. Now what about this? These are variable declarations, this is all the same. And now what is the next difference that we see?
Sir, the input.
Sir, what about that?
You see, this is the way we display something in the monitor. So here we write printf and here we write cout. So now tell me, so this is the fourth difference. Now tell me, what is this cout and cin means? So if I write here, cout, and if I write here printf this, so what is this, and what is this? And I can write here endel also. What is this? What is A? What is B? What is C? What is D?
Uh,
A is console output.
C, what is A? C out?
Console output.
No, be very specific. the purpose is to provide some console output, but I am asking what
Sir,
is
output
cout?
stream, sir.
It is the
Output
out
stream,
object
sir.
in the
Okay, I mean, what
output
is C?
stream.
If I be specific, what is C?
Console.
What is this? In programming terminologies, what is this?
String.
It's a string. So I must. So this is a specific answer that I want, that I seek. So what is C out?
String output.
No, it's not
Method.
an output. Output is shown in the screen.
It's
What
a
is
So it's
function,
an
sir.
object of the class output stream.
Yes, that's true. So that's the answer that I wanted. So this is what? This is an object, right? What is this? This is an object. So C out, that's a strange thing. So C out is an object. And what about this one? This B?
So extraction operator.
It's an operator. So it's an operator. So this is a string. And what is this endl?
New
So it's
line.
basically
Ending a line.
and process the buffer.
What is
So
this?
to break a line, so
Yeah, again, you are talking about the purpose. I am asking what it is. Those who have studied C++, they can answer. I'm not expecting answers from
It's an
those who already
object as
only know
well.
C. They will be knowing
It
it
is an
at the end of the
object.
course, everything, and I am sure many of the pure C coders, they will move far ahead. Those who know C++ right now, I mean, better than that, because everything it depends. So that is not the issue. But I am asking the answers, and because you have probably already are aware of it. So what is D now? Can you just tell me?
So it's a bit by shift operator. Shift left as we call it for C out after C out.
No, this is manipulator. Have you heard of this term?
No, sir.
Anyway, no need to worry about. So the keep answering whether it is right or wrong. Simply don't care, and whatever comes in your mind, you can answer. So thing is, so this object. Now you see, if I get back to my code, did I ever declare an object here? Object means it's an instance of a class need to be declared. So did I declare any cout object here anywhere in this code?
No, sir.
Is that there?
No, sir.
No,
No.
sir.
So that is something very strange. So now you are using an instance of an object which has not been declared yet. So who has declared it on your behalf? Where it is there?
Sir,
So it is there in IOStream,
the
right?
IOStream class.
So IOStream is a library which contains, that's why I stress it so much. It's a library that contains class definitions, and it also contains some predefined objects. And this cout and scene also you'll see, these two are predefined objects which are defined in IOStream library. And these the purpose of scene, as you can see here, cout is something equivalent to printf for displaying output, for providing something in the console monitor, and cin is another object which helps us in getting or extracting information from the input buffer. So if I type something in the keyboard, and so it will extract from that keyboard buffer, and it will extract some information and it can store it in some file. So scene is having the purpose equivalent to scanf. Cout is having the equivalent purpose of printf. But what printf and scanf are? What are printf, scanf?
So functions.
These are library functions. And but C in cout are not functions. These are library predefined library objects, right? So that is the basic difference. Sorry. So this is library functions, predefined library functions, and this is predefined objects, C in cout, right? And this is an operator. So can you see, do you know any other use of this operator? Those who have used pure
Left
C.
shift and right shift.
That's the left shift.
Left shift
Left
and
shift
right
operator,
shift.
right? So this is a left shift operator. So if I write here something like int I equals to 2, and if I write I what will be the output of this? I is initialized to 2, then I give a left shift, 1 bit left shift, to the bits of I. It will be 4 because you're shifting the bit towards the left, so it will be 4 to the power, so it's multiplied by 2. Again I give a left shift, it will be 8, like that. So this in C and in also C++, this is supported. So in C++ also you can use the operator using in this purpose, for this purpose, right? But you can also use the operator, the same operator. You see, the same operator is used in a different purpose, for a different purpose. So what is the example? What this carries as as an illustration of?
Operator overloading.
This is operator overloading, because the left shift operator, which already was doing something, that is left shifting the bits, uh, the bit string of a particular variable, integer variable. Now you use that operator, you basically put another responsibility to that operator, just to what it does. So whatever the string I have got, it will extract the characters or the bits of the string and will display it in the monitor. So that is the purpose it is used for. So this is called, so what is this called? One is the extraction operator and another is the insertion operator. Okay, so this is the insertion operator, also it is called sometimes, but the operator symbol is the same, right? So this is an example of, you can say this is an example of operator overloading. Okay, so without writing any class definition, you see you have started using the feature of operator overloading. You have used so this is basically using this object, you are invoking this operator function. And so what about the other part? So this manipulator, so in C++ you can always within this Fahrenheit you can always write /n, so this will work because it is C compatible, it will work. But you can do it in a much better way. Instead of writing here /n, you can write endl. Endl means end of line, that's the purpose, but endl is a manipulator. So there are a large number of manipulators which are defined and created by say Stroustrup thought of having manipulators which are a much compact way of manipulating the output or manipulating the input. Okay, so manipulators, what they manipulate? So we know the meaning of manipulators in our daily life. Many of us are forced to manipulate things, and depending on the situation, and this is what is related to manipulating the output or manipulating the input. In this case means you have to you have to format, you go to the next line and write something, or when you display the value of 12, you try to adjust it towards the right or towards the left, like this. When you are displaying some decimal values, you just truncate or you just try to round it off up to 2 digits or 3 digits. So all about while you are trying to display some strings, some values in the output, you try to manipulate the output. So there are many other manipulators. I'll have one class on entirely on manipulators. There is endl. Can you specify the names of some other manipulators, those who know it? Apart from endl, what are the other manipulators in C++ available? Do you know setw?
So set
precision. Hello?
yes. So set precision.
Yes, so those are also manipulators. Now you see the endl is a manipulator, and then setw also is a manipulator. You see setw. So using the setw, so we'll have an extensive discussion on that. I'm not going to this here. So setw will set the width of the width, like this is say setw is 6. Now if you display the value of say 12 here, so it may be right adjusted. So this will be left blank and all this. So using setw, you can basically decide to have some leading blanks before a particular integer value. So the setw, and what is the difference between this setw and endl? You see, this is a manipulator which accepts some kind of arguments, and this is without any arguments. So there are manipulators which are designed so that they can accept arguments, and there are manipulators which are just like that without any arguments. And as you can see, the set w appears to be like a function, right? So it's a function like syntax, or function, it appears like a function, but it's not. These are not functions, these are purely input output manipulators. And do you know the header file which are having these manipulators, these special
Sir,
manipulators?
IO
It's
manip.
io manip.h. So this is io manip.h. So this input output manipulators.h. So io manip, if you include, so this endl we don't have to include because the endl is there, but there are some specific manipulators which are included in the io manip library. Okay, so what we can say that using this insertion extraction operator, using the see in see out, and using these manipulators, we can have, you see, much smarter looking input output statements here. What is the advantage you see? If you look into the scanf and this, can you find some advantages as a programmer? Do you have
We
any
don't have to.
advantages in using see in see out
We
instead
don't
of
have to.
printf scanf?
So we don't have to specify like the percentage d, like we don't have to
Yes. So
specify
what are these called?
that.
What is this called? Percent d, percent f?
Format specifier.
Format
Placeholder.
Format
Format
specifier.
specifier.
So
format
format
specifier.
specifiers, in fact, anybody who writes C codes first time, he just scratches his head to recall and then use it and all this. So all these details. And another thing is, you see, often it is found that during writing scanf initially you forget to specify this ampersand, and now you get into a segmentation fault. So these things, these unnecessary hassles can be removed if you just write. So you write C in far, that's all. So it will display the, it will edit the value and it will store the value in that far variable, Fahrenheit variable. Okay, so the format specifiers are not there, they are completely gone. You don't have to recall, and your codes look much smarter, right? Now what is the fifth point? Fifth, can you find any difference in this line, this particular line?
So the type no difference, no difference per se, sir.
No difference. No, this is not the
The
case.
typecasting is different.
So the
Yes.
typecasting, sir, the
Typecasting
typecasting,
Yes,
is
sir.
typecasting. You see, typecasting. So again, it is something like I gave you two images and I asked you to find out how many differences are there in both the images. So this is see float and this is float, but the thing is the way so in a C typecasting, C type typecasting, you say. So this is the data type to be typecasted. It is within parentheses, but here this is like you write the float and then it is like a function type typecasting. Okay, so it's a functional, it's a function format. So you write here, so here you write float x, sorry, here you write float x to typecast x in C, but in C++ you write float, again I'm making the mistakes every time, so float x. So got the difference? So here it is more like looking like a function. So float is as if float is a function and x is the argument that you are passing. It is not like that, but the syntactically there is a subtle change in the syntax. But in C++ it supports both of it, right? So if you write this statement here, it will be working because C++, as I mentioned every time, that it is C compatible. So this function style typecasting is allowed in C++. So then if I come to this point, what is the feature that we find interesting compared to the previous C in C out? What is the other feature that we find that seems to be interesting here? Can you see?
Sir, you don't need to, sir, like for the string parts, there are specific separators for it in order to differentiate which is the string part and which is the data part.
No, I mean, yeah, what I expected the answer is, say in this cout statement, how many outputs I would like to make. So Cout Fahrenheit, I would like to display the Fahrenheit, and then I would like to display the string. Then I would like to display the cent, the value of the centigrade. Then I would like to display the value of the this string, and then I ended. So all these. So how many outputs I would like to make? You see, 1, 2, 3, 4, right? So 4 outputs. How I could have done in a naive way? I could have done Cout, because I know Cout is the object which is displaying the Fahrenheit value. Then Cout, we display the string, right? Then Cout, we display sorry, this Fahrenheit is equal to this this centigrade, and then Cout this centigrade, like this. So because you know Cout, using the Cout object, you can display any value, integer or float value. You can display any string, you can display any character, like this. So instead of doing so, what I have done now, Cout for the string, sent the string, like this. So what is the basic difference between these two? What is the difference between these two? Hello, what is the difference between these two? Are you getting my point? So instead of writing separate Cout statements, I can put them all together, right? You see, I have included all together. So can you name this feature of C++? Can you name what does it mean?
So it is again a case of operator.
Got the point? Can you recall?
Yes, sir.
Those who have used C++
Yes,
extensively?
sir.
Yes,
This is called
cascading.
cascading. And cascading is a very nice feature where you see there are 5 statements. You can combine them all in single one. And then this cascading is a very nice feature which makes even things more compact. So earlier you got rid of the these format specifiers, you got rid of these ampersands and all, and now you find that using Cout you can really cascade. In fact, in Cin also you can do something like this: Cin xy. So you can read 2 outputs or multiple outputs. Say you can write 10 inputs in a single shot, in a single statement. So this is what cascading means. Cascading means just one after the other. You just stitch them together, right? Got the advantage?
Yes,
Hello?
sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
And the thing is, and the nice thing is, you can say if you have got a matrix class, having declared all those 4 matrix instances objects, so you can probably write Cout M1, M2, M3, M4, like this. So what I mean to say is, not only for user defined data types like this, displaying this integer and characters and all strings, but you can extend this cascading feature to have compact outputs for user defined data types like matrix objects or complex objects or whatever, stacks also. The thing is, so you have to write some additional code in the matrix class to make it happen, to make it possible, right? Because we all know, if I write Cout M1, it gets converted to, can you just say that what will be the conversion by the compiler? Cout is the object. So Cout object dot, what is the operator? This is operator. So it's operator this, and it will pass on M1, right? So this is how it gets converted to. So you need to have, in this matrix class, you need to have defined operator function this with all the details that is required for displaying a whole matrix object. Are you getting my point? Hello?
Yes, sir. Yes, sir.
Sir.
So again, the details of why it is required, how it is done, it's different. But if you can make it happen, it is work. And in fact, that particular function, if it returns a suitable return type, again I'm skipping that. It's a reference of that object that I passed. So you will be able to cascade the outputs like this. So this cascading is a very nice facility. Not only can be used with built-in data types, but also it can be extended for user-defined data types. Okay, so that's the beauty of using C in C out. So in C++, using C in C out is not only easy, compact, but it is also adaptive. You can adapt it for new data types that you define, new classes that you define. So in a single shot, we can say that C in C out is easy, compact, and then adaptive, and the last word is a safe. Why we call it safe? Because sometimes in C++, instead of putting here %d, if you put %f or vice versa, you get a different result. So it was not intentional, but maybe you gave some format specifiers, but it was a wrong format specifier, so it will be reading wrong value, so it will be unsafe. Easy means you don't have to recall, compact means you get rid of it in the statements, and adaptive means you can have this cascading or whatever uh, this use of this extraction insertion operator for displaying user defined data types. You can just display a tree, something like cout t, where tree is a class defined and t is the object of that type. So that is a level of abstraction. You don't have to write display tree, you don't have to call. That is a point. So one point that we missed, the seventh point, is regarding the function. It's regarding the variable declaration. Can you find out what is the flexibility that C++ offers you? Can you look in both the codes and find out what is the flexibility that is offered to you by C++ compiler?
Excuse me, sir.
So you can do dynamic typecasting, sir.
No, dynamic typecasting is something completely different. I am not coming to that. Simple. I mean, this is what I mean is variable declaration. Where should I declare the variable in C and where should I declare the variable in C++? So
Sir, I'm having a doubt.
So every time we take scanf,
yes. So the thing is,
we
in C++, there is a declaration block kind of, right? Sorry, in C, there's a declaration block. So it's implicit. It's like implicit, but you know that before you write any executable statement, you have to declare all the variables, declare all variables here. So if you're writing, if you're writing a 500 lines code or 1000 lines code, so whenever you find, okay, now I have to declare a new variable, you have to move up all those 500, scroll up all the 500, 600 lines, and you have to add that new variable name here, right? And that is really tedious because you have to specify that the purpose and all this. But in C++, say I want to declare a cent, okay? Sorry, I myself made the mistake and I'm asking the question. So this is float. That is a problem. I wrote both the codes using C++ compiler and it didn't make any difference, right? So what I mean is in C, I'll be forced to declare, if it's a pure C compiler, I'll be forced to declare the cent as float in the declaration block. But here I can declare it whenever I require. Definitely they should be unique. The two variable names cannot be the same, but it is flexible declaration. So wherever I need, I can declare it for the first time. Flexible.
Sir,
Huh.
sir, regarding the cascading property in C also, we can use single printf to print more than one variable, no, sir? What's
No,
the
that is
difference
fine.
exactly?
That I agree. So using printf, you can always do that. So cascading, but we don't call it as cascading. But we can have the effect of cascading in C. That is fine. That is definitely fine. But in that printf statement, can you display in a single printf statement? Can you create a format specifier for displaying matrix variables?
No, sir.
Are you getting my point? So format specifiers are fixed. So for inbuilt data types, for inbuilt data types, you might have say 10, 12 format specifiers defined. Now, if you declare if you are going to define a new data type or a new say matrix or complex type, can you also define a format specifier for that? We can have a compact display. Hello?
Not possible.
Yes, so that is what I'm hinting. So you cannot adapt. But yeah, I know that for the built-in data types, you can always display multiple variables in a single line using printf. That is possible. So you have the effect of cascading is possible, but the effect of cascading cannot be used adaptively for new data types that you define. Is that fine?
Yes, sir.
And that's the advantage. So that's why I focus on this aspect here, adaptive. Yes, that's true. I mean, in printf, you say that okay, I don't care for cascading because in printf I can print so many variables in a single line. But what I mean to say is, if you cannot display user-defined objects or variables values in the printf because they don't come up with a specific format specifier. So you cannot extend the the symbol set of the format specifiers. That is not possible. Okay, so this flexible variable declaration is another nice aspect of it. So the last point that I'll highlight and I'll end the class. So it is like, can you see this scene.c? So scene.c is what? So scene, I am just reading the value of the character. So what are the other alternatives? So scene.c, sorry, scene this. Do you know what are the other ways to read to read a character in C++?
So get car.
Get char
So
and get
scene, I
line.
can write scene.get. This is another option. Or I can write scene.getC. Got my point?
So
So now, so this we have already done here. So if we would have done like this or this, both of this would have worked. Now can you see any additional feature if I am allowed to use both of these two? What is the object-oriented feature that we can test here through these changes? So what is scene? Scene is an object, right?
So
Using the
get is
dot
a
operator.
member
What is this
function.
get?
Get
What is
is
the
a member.
get? Get is a member function. Belonging to what? Get is a member function belonging to which class? To the class to which scene belongs to, right? So the thing is, iOS is the base class. It is the kind of super class kind of thing. Now within the iOS you have got the iOS class, you have got the iStream class, and you have got the OStream class. Class you all know by this time. So iStream is a iOStream class and OStream is iOS. So it has got a inheritance relationship. So this iStream class and OStream class are both of type iOS type, right? And this OStream scene is basically an object belonging to this particular class. And cout is an object belonging to OStream class. Okay. So in this particular class, you can assume that this get is a member function here, as this scene is an instance, object instance. So get is a method defined in this iStream class. So that's why using scene you can write scene.get this. But what I mean to highlight is scene.get. So can you see there are two variants of get that has been defined in iStream class? Can you see, all of you? There are two variants. One is scene.get. It accepts void, but it returns the type of the character type that it has accepted. Now here it is scene.get. You are passing the value, the variable as an argument and returning void. Can you see the difference? Hello.
Yes, sir.
So
Yes, sir.
what is the illustration? Which feature is illustrated through this?
Function overloading.
Inherit.
This
inheritance,
function
sir.
overloading, because get is a function or a method. As I mentioned, it's a predefined method in a predefined class iStream, where scene is a predefined object. So you have got two different ways, two variants of calling get. One is by passing void, by passing the character variable itself. So this is example of function overloading, right? So you see in this very fast code, just like writing few 6 lines of code, we can try here by changing this to C into this. We can try here function overloading. We have already experienced operator overloading. We have found the strong type checking issue. We have used different you have the flexible function variable declarations. You have got the different style of type checking, typecasting. We have also experienced the different ways of commenting lines and all this. Okay, and we have also experienced the cascading. So there are so many features that we have used. We have used polymorphism, we have used objects without declaring them, we have used function overloading, operator overloading. So there are so many things that we have used by this time, and I'm not specifying this user using namespace. So namespace I'll discuss, so just ignore it for the time being, right? So this is what we do without even writing any class definition. So this is a perfect, object oriented code, as you can see. And because you have got predefined classes and objects, you don't have to even write a single piece of class definition, but still you can use so many object oriented features here, right? So let me just I'll take 2 minutes. So this is the C code here. You see I have written just like this. So I'll be running it in Ubuntu. You see it gives a warning, right? Because it's a C plus, it's a compatible compiler, but it gives a warning. If I ignore, it will start running. Okay, and if I don't have much time, so let me just show it like this. So this is a C++ code. Can you see the screen?
Yes, sir.
Is it visible? The font size?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So now if I write, so for C I use here GCC. So this will be G++ and C++. And what is the file name? Okay, this first C++ code.c. So G++. Now see there is no problem, and if I write enter Fahrenheit 34, and it now I write 56, so it keeps on continuing like this. If I give capital Y or small y, no, it exits. Now if I make a change here, like if I remove here the void, let's see what happens. Then also it works, but it will not allow me to remove this one. Sorry. If I ignore the return type, okay, it's probably skipping that error message, but it should have informed. I mean, because it's strongly type checked. And another change is if I this is a C++ style typecasting. If I switch back to C style typecasting, still it will work. There is no compilation error. Okay, so you can make many such changes here, and you can see how it is working. Okay, so let us stop the class, because so these are the basic changes. So in the next class I'll be talking about manipulators. So those who are aware of it, those who are not aware of it, manipulators, there are many study materials on that. So the basic manipulators of how we manipulate the output of floating point values, strings, and also integers, you try to understand. So, and the kind of problems or small assignments that I'll try is to display number pyramids using manipulators. So how in a compact form we can display it, we'll look into that, right? So this just to give some idea that what will be the next class talks, and then so it is like if I display a number pyramid, okay, if I display a number pyramid like this, so if I don't use manipulators, I might be using 3 or 4 loops, for loops. But if I use manipulators, I might end up with having just only 2 loops. So I can reduce the number of loops, because if I use manipulators. There are, so I would suggest you to go through the library iomanip.h. Okay, and you should all install Ubuntu, maybe Ubuntu Canonical or whatever, and you should also have some nice editors. I think you are already having that. So don't use Turbo C++ or Borland C++. Try to use some ANSI compilers so that you don't have too much of dependency on the compilers, because they provide too many additional features, right? Pure C++ compilers. And there will be one more program that will be discussing about, if time permits. So it will be like this. So if I have got a sine curve, so I'll be trying to display, it's like a plotter. Using the manipulators, I'll try to display that code. Okay. Okay, that's the end of today's class. Recording of photo. So do you have any question?